Innate immunity is the immunity you're born with, and it includes both physical barriers, such as the skin, and it also includes some more internal defenses. When I say internal defenses, I mean like cells like phagocytes and natural killer cells, things like inflammation, antimicrobial proteins, and fever. Innate immunity relies on two very broad categories of cells for defense. And these cells are very not specific. They'll eat anything they don't recognize. There are phagocytes and there are natural killer cells. As we discussed, phagocytes destroy pathogens by engulfing them in vesicles, and then after which they break down those vesicles and spit out the remains. Innate immunity is your first line of defense. And this defense begins with your skin and your mucous membranes, which is one of the four types of membranes in the body. And it's the type of membrane that lines openings to the outside. But what if you get a cut that breaches the skin's defenses? What if it gets infected by a pathogen? At that point, your internal defenses take over and they use immune cells and chemicals to attack the invading pathogen. The arsenal of chemical weapons that your immune response includes inflammation, the secretion of antimicrobial proteins, and as I said, fever. Adaptive immunity is the body's more specific immunity that creates memory. Unlike your innate immune system, which is not specific and attacks anything that it just doesn't recognize, anything damaged or unknown, adaptive immunity is very choosy. Adaptive immunity will only attack specific threats, and it is only carried out by two types of the lymphocytes, B cells and the T cells. Like all blood cells, lymphocytes first develop in bone marrow. B cells stay in the bone marrow and they mature there. Immature T cells migrate to the thymus, not the thyroid. Everybody gets that mixed up. The thymus, and that is where T cells mature. These lymphocytes, they become what is called immunocompetent, and then they have to be self-tolerant. So in other words, these cells have to be able to evoke an immune response by recognizing an epitope, and they also have to make sure that the immune response is not evoked against your own cells, which would pretty much be the definition of autoimmunity. Adaptive immunity has three very important underlying traits. First, it is specific. It recognizes and attacks only specific pathogens. Secondly, it's systemic. It is a widespread reaction. It's not limited to a localized region of the body. And lastly, adaptive immunity has memory. In many cases, if not all, we just have to confirm that by research, but in many cases, once you're exposed to a virus, your body remembers and you become resistant to that infection. There are four very general phases of adaptive immunity that they reflect more specific cellular processes that are happening, mostly in the lymph nodes, but elsewhere. First, the pathogen has to gain entry, and it has to gain entry and pass destruction by all of those innate defenses, fever, macrophages. This can take 5 to 7 days. The next phase is when your body is just kind of just recognizing that there's an infection, just recognizing the pathogen and kind of like deciding what to do about it. So this can take 2 to 3 days. There's a lot of coordination that happens. And then for about 2 weeks, your T cells and B cells mount their attack on the pathogen. This is the adaptive immune response that clears the pathogen from your body. But it's also not the last step. The very last step, the fourth step, is to establish memory, which is the basis of adaptive immunity. Your cells remember for next time. Innate defenses even the NK cells are incapable of establishing memory. Let's summarize what we've learned in order to contrast innate immunity and adaptive immunity. Innate immunity can also be called general immunity. It's very quick in its response to invasion by a pathogen, but it's also nonspecific. Pathogens are recognized as being not self, but their specific identity, it doesn't matter for innate immune cells such as neutrophils and macrophages. Innate immunity involves cells that secrete chemicals called cytokines. And it's these cytokines that then coordinate with the cells of adaptive immunity. And this is why it is so difficult to tease apart innate and adaptive immunity because it's never like one of them works alone, they always both work together. By your innate defenses coordinating and including your adaptive defenses in the response, you'll get clearance of the pathogen or removal of the infectious agent. But notice how adaptive immunity, down at the bottom of this diagram, it has just one more step in there that's included. That's a little bit different from the steps that innate immunity takes. Adaptive immunity, also called specific immunity, is for your long-term defenses. And that's because it creates memory cells. What also differentiates adaptive immunity from innate immunity is the stimulation of B and T cells. These very specific lymphocytes respond to a very limited number of epitopes. And these lymphocytes are also capable of migrating to the infection site to perform pathogen clearance.